So now we know the definition of vectors, but what do we do with them, right? Good question. We are going to treat them as geometrical objects, number one, but number two, mathematically, we can actually do some operations with them, okay? And again, they are described using a number and angles. So how do we do math with the numbers and angles? Well, kind of similar to what we would do normally, right? But let's see it in more detail. Okay, the first operation we're going to do with vectors, or the first way to change a vector, is through an operation called scalar multiplication. And so we just learned that scalars are a number, right? So what we're going to do is just take a number times a vector, and well, what does that do? Okay, and so we see that algebraically, if we do scalar multiplication by, say, a number c, we just have it represented as this form CV. C is a number, okay? So 2v, right? Okay, we'll worry about the arithmetic in the next section, but I want to focus on what the geometry says now. Okay, so we have some vectors here, and then it says draw 2v, 1/2 w, -3v, and -w over 4. We might do some of them, but not all of them. Okay, so the idea with 2, okay, that's a scalar quantity. We're taking the vector and multiplying it by 2. Okay, what's that 2 do? Does it change direction? I don't know. Okay, but really what this is saying is that if this is 1v, well, 2v would be just twice as long, right? So in fact, that's actually true. So if we look at 2v, and I'll do this in blue, this is saying take v and make it twice as long. Increases magnitude, but not its direction. Okay, so this would be v, and then so in total, we'd have 2v. Okay, and again, when you're drawing vectors, make sure to include that arrow above the v. Okay, so this number in front just acts as like make it, twice as long, half as long. Okay, so in the case of w, okay, I'll do this in red. If w is like that, I'm going to proceed from the initial point of w towards the terminal point. Okay, terminal point's down here, but I'm going to stop halfway in between. There's about halfway. Okay, so I'm going to do this in red, and this shortened vector would be 1/2 of w. So I keep the direction, just take the length of the vector times whatever the number in front of it is. Okay. Oh, but goodness, the story changes. -3v. What does negative do? Well, it would be -3 times as long, but lengths can't be negative, right? The negative changes direction, and specifically it's the opposite direction. Okay. Okay. So then for v, right, if this is normal, the normal direction for v, okay, I'm going to call that v in the opposite direction, and then I just need to go 3 times as long. So maybe there's one, and then, or there's a second one, and then maybe here's a third. Okay, so I'm going to call this is going to be minus v, this is another minus v. So in total, this distance here is minus 3v. Okay, and then finally the last one is minus w over 4. Okay, so I want you to pause the video, try this out. What does the minus do? What does the division by 4 do? Okay, resume the video when you're ready to see the solution. Okay, and I'll actually do a walkthrough. So I'm going to say it's right about there, and it's in orange. Okay, minus w over 4. Okay, if I write this out a little bit differently, I can pull the minus out and the 4 out front, because ideally what I'm looking for is like, what is that number in front of w? Okay, well, that's just the 4 can come out, the negative can come out. What can come out over here? Just a 1. Okay, so I'm really saying that in this representation that 1/4, or that negative w over 4, is the same as negative 1/4 of w. Okay, so what I did then is made it go in the opposite direction and have about 1/4, which would be, I don't know, about there, just in the other direction. Okay, so there we go. All right, so we kind of did the scalar multiplication by trial and error, but what are the conclusions? If c is greater than 0, then the length of the vector is multiplied by c in the same direction. And in the case where you're multiplying by a number that's negative, it's going to be the length of the vector is multiplied by, I'm going to say the absolute value of c, okay, because c is negative, so we want to multiply by the positive in the opposite direction. Okay, so just keep in mind that if you have a negative, it switches direction, but otherwise, if it's positive, keep the same direction, multiply by c. All right, so that's scalar multiplication in a nutshell. So make sure to keep this in mind as you work on drawing vectors geometrically and their scalar multiples.